So in this question, we've been asked to find the reactions slash the supports. And so the reactions are at this roller. There's only one because the roller only supports vertical force. And then at the pin, there is a force in the X and a force in the Y. So we'll call this RAX and we'll call this R point A in the Y. So that means we've got three equations of statics. Sum of the forces in the X is 0, the sum of the forces in the Y is 0, and the sum of the moments at a particular point, we've got to decide that point, equals 0. And I'm just going to decide that point right now. We're going to say at point A. That's where we're going to sum our moments. So first I think it's important to identify the forces. I've got a 60 kip force down, a 100 force kip down, this RBY, and a 2 kip force in the right. That means it's easy to sum the forces in the X, so I'll go ahead and do that first. In summing the forces in the X, we have RAX plus 2 kips equals 0, or RAX equals negative 2 kips. So that means it's actually to the left. And I'm going to label that. I'm going to say it's going left because my drawing had it going right. And so we're just going to leave that work there, but we're going to erase it so we have space and can see the picture. RAX equals 2 kips to the left. Now we're going to look at our sum of forces in the Y. Actually, we'll wait on that because I know that that's not going to give us a final answer. It's just going to give us one equation and two unknowns. So I'm going to go to my moment equation, and I'm just going to simplify this. Hey, we've got this point right here is where we're allowing rotation. So this is at A, and we have 60 kips down, so it's going to cause that kind of positive or clockwise rotation. We've got 100 kips down. It's going to also cause this kind of rotation. We've got RBY. It's going to cause rotation the other way. And the last one is up here. I've got a force here. It's going to cause also clockwise rotation. So I have M1, M2, M3, and M4. 4 moments I better consider. So in thinking about moment 1, I have 60 kips times its distance from point A, which is 3 feet, causing rotation clockwise. Then I have 100 kips. It's through a distance of 10 plus 3 is 13. To the right, it's moment 2. And then moment 3 is going back the other way. So it's minus RBY times its distance is 10 plus 5 plus 3 is 18. That would be feet. And then I also have this M4, and M4 is coming from, I'm just going to draw it out over here. It's like a sine here, and we're pushing at 2 kips, and the perpendicular distance from where it's supporting is 5 feet. So 5 times 2 is 10. And it's causing this 10 to go clockwise. So we're going to say plus 10. And so this is actually a pretty easy problem. The math is easy anyway, the arithmetic. 60 times 3 is 180. 100 times 13 is 1,300 minus 18 RBY plus 10 equals 0. So that means RBY will equal 1490 over 18, which is 82.78. And I'm going to actually store this as alpha A on my calculator so I don't have to worry about rounding. So now that I have the moment correct, or now that I've used the moment correct to find one of my reactions, I'm going to find the other reaction using the sum of the forces in the y equals 0. So let's go back and look at our picture. We've got 60 coming down and 100 coming down, and then RBY going up and RAY going up. So we'll say we have RAY, which we haven't found yet, plus 82.78, really this is just alpha A, minus 60 minus 100, or RAY, and all that equals 0, so we'll have 160 minus alpha A, RAY is equal to 77.22. Both of these assumed directions of up were correct. So now we're all done. We've found both reactions, RAY and RBY, both going up.